Okay, good morning. It's October 5, 2023. The time is 4:02 a.m. This is Professor David J. De Los Reyes. Okay, my topic for this session will be a continuation of my college algebra, and we are now on lesson number 82. Okay, let's proceed. The subject matter for this morning will be college algebra, lesson number 82. The title of the topic is there are two topics, the point slope form and the so-called slope-intercept form of linear equations. Okay, for this morning, we'll try to derive the general equation for the point slope form and the slope-intercept form, meaning we are to derive these two equations here. We just don't just use a general equation. If we could bring out the derivation, it's better for us. Okay, let's try to bring out the derivation of the point slope form. Point slope form meaning if we are given the slope and one point on the line, okay, we can find for the equation of that one. If we are given the slope, okay, and we are given point number 1 with coordinates x1, y1, okay, we can find for the equation of the required straight line. So to bring out the equation of the required straight line, I will try to erase this one so it looks good. We'll start with the derivation. It will be something like this. From the previous discussion, slope is actually the change in the ordinate over the change in the abscissa, or the difference in the ordinate as numerator and the difference of the abscissas on the denominator. Oh, that is a general equation on how to compute for the slope if we are given 2 points on the straight line. So to compute for the slope, we are given 2 points, right? It will be point P1 and point P2, x1, y1, x2, y2. So if we are given these 2 points here, actually by using this formula, we could compute for the slope, right? So this will be the slope. Y2 is given, y1 is given, x2 is given, x1 is given. So slope over here will be a certain constant c, right? But for the meantime, we leave it as just like that. I just place as equal to c because if we try to compute for this, what will come out will be a pure number. It could either be a plus or minus, right? And again, by using the equation or the formula, slope is actually the difference in the ordinate over the difference in abscissa. Okay? We forget so what will this? We forget P2. Okay? And again, we try to take the slope considering P1 and any point P on the line with the coordinates xy. Okay? No more coordinates because we are solving for the equation already. So considering for the meantime point P1 and this point P here, again by using this slope formula, M should be equal to, it should be the difference y, the ordinate of this point here, minus the ordinate of this, minus y sub 1. Okay, and this should be equal to x, the abscissa of this point, minus the abscissa of this, that is x minus x sub 1. And if we try to simplify this one, y minus y sub 1 should be equal to the product of m times the quantity x minus x1. Because to remove the fraction on the right hand side, we multiply all terms by x minus 1. So the left hand side should have a multiplier, the quantity x minus x sub 1. So the general equation for the so-called point slope form is this equation here. Okay? Y minus y sub 1, and this should be equal to m times the quantity x minus x sub 1. No more subscript here. Okay? Because we are solving for the equation, right? And this point P here with coordinates xy lies on the straight line. So this is general equation number 1. As simple as that one. Okay? So memorize this by heart. Because if you are solving problem that involves a point in a slope and under the study of analytic geometry, you will be using this one. Okay, the next equation. The so-called slope-intercept form. The slope-intercept form is this one. Y is equal to mx plus b. We'll try to derive this one because it just then came out. There should be a derivation for it. And again, by using the same figure, okay, for this figure number 2, the first point we are considering what's happening? That right out. We consider this point here as point P1. Where is point P1? It is at the it's at the y-axis. This location here is actually termed to as the y-intercept. Meaning for this second figure, we are given this point. And the coordinate of this point is actually at 0 and b. And b is actually the y-intercept. Right? What is also given for this given figure? For this given figure, the slope of the line is given. Right? And to compute for the equation of any point that lies on the straight line, we consider this one as point P with coordinates xy. So again, by using the formula is actually the difference in ordinate over the difference in abscissa. And considering point P1 as 0 and B, okay, we'll take the coordinates of this, we place it here. Right? So what will come out? M now equal to, if we try to take again the slope of this, considering this point P and this point P1, okay, it should be the difference in ordinate, right? So this is y. The ordinate of this point is actually b. This is minus b. And all over, the abscissa of point P is actually x. No more subscript because we are solving for x as a function of y. And what's the abscissa of this point here? The abscissa of this point that lies on the y-axis is actually 0. So this is minus 0. So actually it seems the denominator is just simply x. Okay? So if we try to cross multiply or just multiply all terms by x, right? M times x will be mx. A y minus b over x, this x here cancel with this. So what remains on the right will just be simply y minus b. And if we try to compute for y as a function of x, we'll put this one here on the left, then we try to rearrange the equation. So y now equal to mx, okay, this is plus b. Or this is actually the so-called slope-intercept form. Why it is called the so-called slope-intercept form? Because for this formula here, we are given the slope and we are given the y-intercept. So for any straight line in which the slope is given, the y-intercept is given, we could compute immediately for the equation. That is by using this equation here. That is y is equal to mx plus b. So the ones they are bringing out on the short video formats, y equal to mx plus b emanates from this, right? this was the derivation. So the formula you're using on the short videos, okay, on YouTube, y equal to mx plus c, this is the derivation. Okay, that's it guys for this morning. So I just presented two equations, the point slope form and the slope-intercept form. So as long as you are solving a problem in analytic geometry in which the slope is given and the y-intercept is given, okay, you can use this equation. And for the first one, if we could compute for the slope, right? And considering the first point, to solve again for the slope, the required equation will be y minus y1 equal to m times the quantity x minus x1. And this is the so-called point slope form. Meaning, we are given 2 points on the straight line. So actually, we could compute for the slope. Then, to take the slope again, in terms of x and y, we just consider 1 point. So the resulting equation will be this. Y minus y1 equal to m times quantity x minus 1. Okay, that's it guys. This is Professor David J. De Los Reyes. Good morning from Los Angeles.